Hello friends, welcome to Input Output YouTube channel. So friends, today we will discuss about a very important coding questions which is asked many time in Nagarro Coding Test, and this question is also very important in other on-campus and off-campus exams. So here we have to find the nth prime number. You are given an integer n and the task is to find the nth prime number. Suppose you are given a number n, suppose n is 1, okay, and you have to, so the output is 2 because the first prime number is 2. If you are given a integer n equals to 5, then the output will be 11, and if the input is 1049, then the output will be 8377. So this is a prime number 8377. So friends, I guess you all know how to calculate a prime number, but we'll use the best method to calculate the prime numbers using shift of Eratosthenes. Hope you know this algorithm. If you don't know, then I'll show you how to calculate a prime number using shift algorithm. So our approach is, so first we'll find prime up to some certain numbers using shift. So first prime calculate using shift, and next what we'll do, store all the prime in a container. So here our container will be, suppose, vector. So vector will be easy to understand. So next, so for a given n, n is the input, will return n minus 1, because we'll store the prime numbers in an array and will return n minus 1 because the array is start from, by default the array start from the index 0, so we have to return n minus 1. Okay, so this is the approach. Okay friends, so our first task is to format the C++ code. So first we'll write hash include hash include with standard C++.h using namespace standard and then int main. Okay, so yeah, so our limit will be n equals to suppose okay, we have define this as define max size. Okay, the max size, suppose the max size is 100000. Okay, this is our max size. So next, int nth. So nth is the n is a variable which you want to calculate the prime number, nth prime number. So we'll take an input nth and sif. We'll first, so sif is the name of a function, and we'll first these two variables n and nth, and here we'll just write void sif and int n int nth. Okay, so these functions is very important because this is the algorithm of sif. And first we'll declare a vector, inter vector, and the name of the vector is v, suppose v. And next we'll declare an array. Let's say the array name is prime and size is n plus 1, and this is boolean type vector. Okay, so next we'll declare memset. So if you don't know what is memset, okay, so memset is our initial array was prime and it was size of n plus 1, and using memsets, so we can write memsets like this, and inside these memsets we first have to write the name of the array, and then we can write true or false. If we write true, then the every position's value of that array, prime array, will be true, and then we have to write the size of prime. Okay, this is how the memset works. And then we'll write the for loop for int p equals to 2, p into p less than n p plus plus. Okay, so if prime of p equals to true, if the p value of the prime array is true, then we'll and here prime of I equals to false. So friends, for the first for loop, we have iterate from p equals to 2. Then for the p value of 2, we just entered into the for loop, and then we check if the prime of p equals to true. If this is the true, then we'll just double the p value, p into p, and then we'll make it false, because if the first value is 2, with the second for loop we can go to the 4 6, okay, sorry, 4 6 8 10, and like this, and we'll just make these 4 6 8 10 12 false in the primary. Okay, so similarly we'll do for the 3. Okay, so that's how the sif of Eratosthenes algorithm works. Okay, our next step is storing the prime values. So for int j equals to 2, j less than n, j plus plus, if prime of j. So prime of j equals to true. If prime of j equals to true, we'll just store it into the vector. So v dot pushback j. If the prime of j is true, so in this for loop we iterate from 2 to the number n, and if the prime of j equals to 2, then we'll push that value into the vector v, because if the value is 2, then this is the prime number, and we'll just push it into the vector v. Okay, and at last what we'll do, we'll just output it. So output what? Output v of nth minus 1. Nth minus 1. Because you know our array starts from the 0 value by default. So we have to write here n minus 1. So now we'll run the code. Let's see what happened. Okay, suppose 5 is the given input and 11 is the output. So let's run it once again. Okay, it's compiling. Suppose our input is 1049. Let's see what is the output of this input. Okay, 8377, and you can see here that the input was 1049 and the output was 8377, and that matches and our program is correct. So friends, hope you enjoyed this video. If you like this video, then give it a big thumbs up. And if you are new to this channel, then please subscribe to our channel for new videos, new solutions. So friends, till then, take care. See you in the next video.